Saxon Course 3, Lesson 1, Number Line, Comparing and Ordering Integers. With this lesson, we're going to be looking at a number line and putting numbers in different types of sets. A set is a collection of items like numbers or polygons. We use braces to indicate the set of numbers. Let's take a look at a set of whole numbers. Whole numbers start at 0 and keep moving forward. 0, 1, 2, 3, and it continues. Next, we have counting numbers, which starts at 1 and continues. 1, 2, 3, 4, and goes forward. The last set are integers. Integers include whole numbers, counting numbers, and also negative numbers. You see that it has 0 in the middle, and it goes -1, -2, -3, and continues to the negative side, and goes forward, which has 0, 1, and 2, and then it continues. If you take a look at each bracket, you notice that there are whole numbers that's a part of counting numbers, and there are counting numbers that are part of integers. Each of these actually contain each other's numbers. We'll need to know that further along in the book. That counting numbers is a part of integers, whole numbers is part of integers. Same thing, counting numbers is part of whole numbers because they have the same exact numbers included in their set. Now let's talk about the absolute value of a number. The absolute value of a number is the distance between the number and the origin. And of course, the origin is actually 0. Let's do an example so you actually understand what this definition actually means. The absolute value of -5. The two straight lines that are beside -5 mean absolute value. We've got to remember that these lines mean absolute value. Now, the definition once again for the absolute value is a number that is the distance between the number and the origin, which is 0. So on a number line, I have the numbers out to -5. The definition means the absolute value is how many steps it takes to get from -5 back to 0. And the best way to do it is show by little humps. 1, 2, 3, 4, 5. It took 5 jumps to get back to 0. So the absolute value of -5 would be +5. It took 5 different steps to get back to 0, which is our answer. Let's do a few examples as a good reminder of what we've learned in this lesson. Example 1. Arrange these numbers in order from least to greatest. When we are looking at the original number line, we saw that after 0, it kept going -1, -2, -3, and then keeps going. From 0 going to the left, the bigger the negative number is, the smaller the number actually is. So when we're looking at this example 1, we have -3, 3, 0, and 1. Which of those numbers is the smallest? -3 is. Next smallest, 0, then 1, then 3 is your answer. Example 2. Compare. Less than, greater than, or equal to. In this example A, it says -3 is less than, greater than, or equal to -1. Which number is the largest? What number is the biggest? -1 is the biggest number. We have to remember that rule that says the bigger the negative number is, the smaller it actually is. So our answer would be -3 is less than -1. Let's look at B. The absolute value of -3 is less than, greater than, or equal to the absolute value of -1. When we're looking at this equation, we actually have to solve it before we can actually answer it. What is the absolute value of -3? If you remember the absolute value of -3, to figure that out, we have to think about how many steps it would take to get from -3 back to 0. And of course, if you notice, it's automatically a number, but makes it positive. It makes it 3. It'll take 3 steps for it to get back to 0. What about -1? How many steps would it take to get back to 0 from -1? 1 step. So which number is the biggest? The 3 is the biggest, which means 3 is greater than 1. The absolute value of 3 is greater than the absolute value of -1. Example 3. Graph the numbers in this sequence on a number line. So here is this set of numbers. We have ... -3, -1, 1, and 3. So we have to graph those 4 numbers on a number line. So we're going to start, of course, by drawing a number line. Put 0 in the middle. And of course, move forward on the number line with 1, 2, 3, 4. And the same thing with negatives. -1, -2, -3, -4. Now it says graph the numbers in this sequence. When we graph these numbers on the number line, all we do is find the number and put a dot on it. So it's -3. So you put a dot on the number line at -3. -1, put a dot on the number line at -1. +1, put a dot on the number line at +1. And then +3, put a dot on the number line at +3. We graphed these numbers on the number line, which that is our final answer. Example 4. Graph 2 numbers that are 4 units away from 0. Now listen, when it comes to word problems, you have to look at every scenario, everything that's given, everything that the equation is actually saying. So a key word here says graph. So we know for a fact we are, Miss Brewer, what numbers do I need to put on the number line? Well, what numbers are given? 4 and 0. So let's go ahead and put a 0. Count up to 4 on the number line. And -4 on the other side. We always have to make sure we see everything that the words say in a word problem. Now let's go ahead and figure out what it's actually asking. Graph 2 numbers, that means we're graphing 2 separate numbers that are 4 units away from 0. 4 units away from 0. So we have 0 that is right here. And we have to figure out a number that's 4 units away. And what's so cool about this, you notice from 0 there are 2 numbers that are 4 away. The +4 is 4 units away. and that is -4. That is also 4 units away. This shows absolute value in this example. Shows you how you get the absolute value of numbers, of how the units are separated from 0. If you guys have any questions, please make sure you come and ask. I'm always here.